Hey guys, let's go over lesson 2.2. What are we going to do during this time? Learning targets. After this lesson, you should be able to. Learning target number 1, distinguish between explanatory and response variables of quantitative data. We did that last lesson with categorical data. Learning target number 2, make a scatter plot. So this is a new graph to display the relationship between two quantitative variables. And learning target number 3, describe the direction, form, strength, displayed in a scatter plot and identifying our outliers. I'm going to call this one SUDS for strength, unusuals, or outliers. D for the direction, and the form is the shape. Okay? All right. Learning target number 1, EV and RVs, right? We talked about this before. Why do we study relationships between two variables? Because we want to explain why things happen. And what do we do with that? We can make predictions. What is the difference between EV and RV? We kind of talked about this in the last one. We said that the EVs, explanatory variables, may help us predict or explain changes in a response variable. Or another way we said it was that the explanatory variable and explanatory is the variable x helps explain. So hopefully you see the EX and then the variable x there. And then last time we said that the RV measures an outcome of a study. The response variable, which is the y variable, focuses on the results. So response, results. Okay? And then we talked about how it's a question, does the x affect the y variable? And we're not using this word yet, causation. All right. So how can we display the relationship between two quantitative variables? Let's review one quantitative variable. Do you guys remember which displays that was? Yeah, you take some bunch of numbers and we can make it a box plot. We can make it a histogram. What else? There were dot plots. So we could have used all of those, but for our case here, when you have two quantitative variables, again, look above, the EV, RV, those are the x's and y's, you have something called a scatter plot. All right, so how do we know which variable to put on which axis? Okay. Remember we talked about above the explanatory goes, where do you think? On the x-axis. And this is similar to the independent variable in algebra. Okay, so what do you think that means for the y variable? So what colors do we use back up here? The response refers to the y-axis, because we're worried about the results. So the results are going to go on the y-axis. And this is like what? This is similar to the dependent in Algebra 1. Another way of putting it, the input, which is your x, remember we talked about the blue here, explains the output, which is your y. The input, what you put in, explains the output. So, where do we start each axis? Does not have to be the origin. You don't have to start at 0, 0. Remember, you can use those earthquakes. I hope it never comes, but lots of statistics. And you can also start with what makes sense. Start with what makes sense based on the problem. Based on the problem. Okay, that's page 1. Let's go ahead and try some examples there on page 2. All right, let's try these examples. Example 1, EV and RV. Identify the explanatory variable and the response variable from the following relationships. 1a. You visit a local Starbucks to buy a mocha frappuccino. The barista explains that this blended coffee beverage comes in 3 sizes and asks if you want a small, medium, or a large. The prices are this, this, and this respectively. Okay, so let's think about this. Which one explains the other? Blank explains the blank, right? Whoa, I wanted to use orange. Explanatory variable explains our response variable, the results. Well, what's the results? The results are the prices here, right? Oops, sorry. Well, what explains the prices? It's the sizes. The size is the explanatory variable because it explains the prices, right? If you get small, you're going to pay less, and if you get a large, you get pay more. Does that make sense? Let's try another one. How does drinking beer affect the level of alcohol in our blood? The legal limit for driving in most states is 0.08%. Student volunteers at Ohio State drank different numbers numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol content. So we're looking for an EV, the response variable, and we're figuring out which one explains the RV. So what's the outcome? Well, what a police officer trying to measure? The police officer is trying to measure their blood alcohol content. So blood alcohol content. So how much alcohol is in their blood, right? And then what explains this? Well, the number of beers. All right, go ahead and press pause. You try that last one, and we'll go over it in a second. Mr. Shudo swims 2,000 yards regularly to try to stay young. He records his time to swim the 200,000 yards and his pulse rate each time after swimming to observe any fitness. So, what do you think is happening here? What explains the RV? Well, something that can go up or high is his pulse rate, right? You know, if he's just casually swimming, or think about it as casually walking, your pulse rate is low. But if you go fast, so he's recording his time. Time explains his pulse rate. So if he has like a super slow time, like 10 minutes to go across the pool, then he's casually going across or walking across, if you think of it that way, then your pulse rate is low. But if you're like being an Olympic swimmer, you're on the swim team, you're trying to go fast, then if you have a smaller amount of time, then your pulse rate's probably going to go super high because you're exerting a lot of energy. Okay? All right, learning target number 2. We're going to make scatter plot. So how do you make a scatter plot? Number 1, you need to decide which variable should go on each axis. Remember, we talked about that the explanatory variable goes where? Goes on the x-axis. Number 2, label and scale your axis. Those tick marks. And then in context, what is it talking about, right? Size of the coffee. Number 3, plot individual data values. It's going to be the order pairs in quadrant 1. All right. So learning target number 3, describe the direction, form, strength of relationship displayed in a scatter plot and identify any outliers. What we're doing here is we are, what's another word for describing? We are interpreting the scatter plot, okay? And so, it's a funny picture. Every time you go to the bathroom, you should always do what? Wash your hands. And when you wash your hands, make sure you use soap. And when you rub your hands together, they create something called soap suds. Suds. Let's make this thicker. S-U-D. And down here is S. So what is suds? First, you have the shape. Can the data be described by a straight line? Can it be a linear? Is it like curved? Is it in clusters? Number 2, is there anything unusual? Unusual. What's another word for unusual? Outliers. Are there clear deviations away from the pattern? Number 3, D in SUDS is direction. What is the direction? If it is upward, then it has something called a positive association. So I'll draw a couple of graphs right here just to make sure we're clear. In graphs, just like in English, we read from left to right. So you're reading the graph. Let's say a bunch of data is going in this direction. So we would consider this positive slope, so positive association. And then if your data is going down, that would be a negative left to right, so going from up here, going down, right? And then or no direction at all, that means there is no association. So you might have data all over the place. These ordered pairs, right? And you can't draw a line through it. And the last one is called strength. And we measure the strength by something called the correlation. Correlation. Okay, lowercase r. It's the extent to which points adhere to that trend line. So that trend line was that blue one. And we're actually going to talk about this. Let me highlight this. This will be in lesson 2.3. So the whole lesson about strength will just be lesson 2.3. All right, so there is page number 2. Let's move on to page number 3 for some examples. All right, page number 3, example number 3, relationship. Is a relationship. Determine whether a scatter plot of data or the following might show a positive, negative for n, or no relationship. Right, no. If there is a positive or negative relationship, describe its meaning in the situation. Okay, so let's look at this. So I'll do the first 2 and then you press pause and you'll do the rest. Number 1, I have temperature versus rainfall. Can you draw a line through that? The answer would be no. So this has no correlation. I don't see a direction in which it's going, right? Number 2, what do you think about the states? What colors did I use? Okay, so I can draw a line, not connect the dots, but kind of where is it going through? So I would say that this one is positive, okay? Or you could just write P, but the better idea is what does that mean? Okay, so what's happening on the X values down here? You'll notice on the X values that as the mean elevation goes up, so as the mean elevation increases, what's happening on the other axis? Where's my data going? The data is going, as you go to the left, the data is going what? Up. So the highest point, so we're talking about mountains and different parks, the highest point also increases. Okay, so again, as you're think of it as like a timeline. Let me see if I can try it in a different, show you in a different way. As you're going from left to right, what's happening to our numbers? Are they going up or down? Okay. All right, go ahead and try examples 3 through 6. Go ahead and pause, and then we'll go over those together. All right, question number 3. Average weekly hours in the United States. Just want to point out they have their labeling their axes. You see the earthquake, which is fine because they're not starting at 0 on the y-axis, right? So this is the y and this is the x, right? Explanatory. And a response. The scales here are counting by 1s on the x, and then here it looks like they're counting by 0.2. Okay, so what's happening to our data here? Well, I kind of noticed this negative trend, right? As I go from left to right, the dots are going down. But you can also argue, okay, that one's a far stretch. I mean, it's kind of far away from the line, isn't it? You can kind of also say, well, oh, does it look curved? And then if it's kind of curved, it's not positive and it's not negative. So you can argue both ways on this one. I would accept no correlation on this one. Or you can say negative as years since, so I'm just using what the x-axis says, since 1995 increases, right? The years are getting bigger. Okay, what's happening to the hours? Hours worked, that's what's happening, right? That's what the hours measures on the y-axis. What's happening to my numbers as I go towards the right? The numbers are going down. Hours worked decreased. So either of those would be acceptable. All right, so take a look at this one, average speed. Same thing, kind of looks curved or going down, so we can say negative. What's happening? So again, you're starting on the x first, so let's kind of make that clear. X, and then what's happening in the y's. Does that make sense? So on the x, as minutes jogged increased, what happens in the y variable? Remember, you're going from like left to right, and again, I'm kind of drawing, it doesn't help, I'm trying my best, but as I'm going from left to right, just imagine like there's a line going across your graph. What's happening to that blue line there? The data is going what? It's going down. So the m miles per hour, that was there on the y, miles per hour is what? Decreases. Right, you're getting tired, and I don't know, for me, after I jog like 1 minute, I'm definitely going a lot slower, so my speed is a lot lower. Okay, hours, average US hours earned since 2003. This one's nice. You guys will grow on this one. Is has a source of where it came from. So let's look at our graph here, and again, you see the earthquake, and I notice that my graph is going up, so this would be a positive. And I need the x and then the y. What's happening in our x's? So as years, so I'm just repeating all that. As years since 2003, what happens? Increases. Then again, if you have like if I'm going across, what's happening to that green there? It's going up. So then we can say hourly earnings, so then I'm just repeating what's in the y variable. Hourly earnings in dollars is also increasing. And last one, US imports from Mexico. Can I see going up? So positive. I have my x and my explanatory, the y. So as what? Years since 2003, remember we're going this direction, left to right, as they increase, Then what's in my y? Imports measured in billions of dollars does what? Remember, you're going across here, you're going, and that number is going up. So that would also increase. Okay? All right, go ahead and try these three below. You're basically doing the same thing, but there is no graph. So let's do one and then you do the rest. Okay. Let's do one. Let's do the size. Determine whether the scatter plot of the data of the following might show a positive, negative, or no relationship. Okay, so basically you have to draw them now. So figure out what goes on the explanatory, that would be the x, and which one goes on the y. So which one does the explaining? The size of a family and a weekly grocery bill. This makes sense, right? I have a big family. So what's my results? My results is my grocery bill. Results is the response, which is the y. So weekly grocery bill. Doesn't tell us, but measured in dollars, right? And then what is my explanatory? My explanatory is how big my family is, right? Size of family. And you don't need to fill all this out, but the goal is that you can get a conceptual what's happening, right? So let's just say your family size is 1, 2, 3, 4, 5. And then, I don't know, you could do like 20, 40, 60, $80, right? So what would happen? What would happen if there's more people in the house? Well, if you have like cookies or stuff like that, right? I don't know. I would expect it to kind of go up. So I would say that for this one, there would be a positive. Okay. Go ahead and press pause. Go ahead and try those other ones, and we'll do them together. All right, which one is our explanatory? Remember, the outcome is, if you think about it, the results are measurable. Results are measurable. Although it has numbers, but just think about it. It's kind of like, I don't know, it comes down to the bottom dollar, like what's happening, right? So this is my y, so that is cost, probably measured in dollars. And this one is my explanatory. Remember, explanatory goes on the x-axis, so size of car. And how do you measure size of car? You might have something like, you could do like compact, sedan, bigger SUV, but they also could just do it by like, I don't know, cubic like amount of space. So let's call this, I don't know, cubic inches. Like how much space is in it? 100, 200, 300, 400. And you might be thinking that the temptation is probably to think something like this, right? But let's think about this, okay? I don't know, I like cars. 20, 40, 80. We'll do this in thousands. So you could buy a Corolla. Maybe it has like something in there, right? 200, then you're thinking, okay, like my minivan. My minivan was like, I don't know, $40,000. Okay, but why don't you buy like a truck, right? Sometimes trucks are quite expensive, but they actually don't have a lot of cubic inside. So maybe you have it there, right? But then what happens if you have like a sports car? Once if you have a Lamborghini, which is like way up there, but it's like really tiny. It's a 2-seater, something like that. So what does that look like to you? I would say that this one has no relationship. Okay, does that make sense, guys? It's hard because you have to understand context, right? You may not understand all of those, but that's the harder part. Statistics is not just numbers; it has a story behind those numbers. All right, time spent playing video games and then time spent on outdoor activities. time spent playing video games, and this one is actually interchangeable, right? If I spend time outside, that means, well, you have to think about in context that usually you want your video games, you want it inside because you don't want the sun hitting your plastic, PS10, and you want your screen to be extra bright. So let's just say you like this is explaining the time spent outdoors. And this is your video game time. And what would happen if I spent, let's just put some numbers to it. Let's measure it in hours. So hours, 1, 2, 3, 4. Okay, so it's fall, and so if you spend, say, if you spend 1 hour, let's just say there's 4 hours of sunlight after school. So you have 1 hour outside, then you can play 3 hours of video games. But let's say there's only 4 hours, then you have to split it up. So if it's like 2 hours outside, then you can only play 2 hours of video games, and then 3 and 1, or 4 and 0. Or let's just say you don't want to spend any time outside, and you spend all of it playing video games. Okay, what does that look like to you guys? It looks like a negative. Okay, so these are harder because you have to draw it, and you have to think about a context, and you kind of have to give it a direction. Okay, so that was page 3. Let's try page 4. All right, let's go ahead and graph this one. Example number 4 on the next page. Tourist, you work for the Bureau of Tourism in Miami. To start, you find the number of overseas tourists who visited Miami during the past 8 years. Okay. In this problem, it was just referenced as this is now. Put my pencil on. This is now, as in years ago. So that was 1 year ago, 2 years ago, 3 years ago, 4 years ago, 5 years ago, 6 years ago, 7 years ago. Or if you think about it, past 8 years is 1, 2, 3, 4, 5, 6, 7, 8. Just trying to help you explain the context a little bit, okay? And then tourists are measured in thousands, okay? So what I like to do is when I see that scale, I just actually write the word 1,000. So you just multiply that number by 1,000 to give you an idea. So why do they do that? Notice there's 3 zeros, so you just add 3 zeros here. 1, 2, 3. And you have 3.2 million. Let's write that. And that's just to give you context, right? I think that's where we're putting numbers to a story, okay? So it tells us my explanatory, let's just highlight that. Orange, guys. That's what I'm going to put. So let's go ahead and put in orange tourism in the past 8 years, okay? So you have years, 0, 1. The distance between my tick marks here is, you want them to be equal. If we were in the classroom, I probably would have asked you to use your ruler. Digital, I think we're just kind of giving the rough sketch here. And then this is tourists measured in, that's going to go on this side, right? So tourists, just copy all that, tourists in thousands. And this one was nice because it kind of tells you, look, that's the y variable. Okay, so what kind of scale am I going to use? You can use a really broad one if you want. maybe do like 1,000, 2,000, 3,000, 4,000. And it's okay if you put extra tick marks in there. You don't have to label it all. It'll get kind of crazy, but now this one's definitely super important, okay? And let's just go ahead and put our points. So 0, just think of it as an ordered pair. 0, 3,270. 3,000, that's 3,500, so somewhere in there. 1 and 3,000. 2 are around 3,000. 3 and 2,700. 4 and 2,500. 5 and 2,300. And if you think about what we're doing this by hand, so there's definitely a lot of estimating, and then 7 there. Okay, and guys, for right now, it is a scatter plot, so it looks like just a bunch of dots. Okay, you're not connecting the dots right now. All right, you guys try question number 5, and then I'm just going to press play on it, and it'll just have the answers, and then we'll go to the next part, because it's learning target number 3 is describing the scatter plot. All right, so body weight is the explanatory variable, my x, body weight measured in pounds. And how do you pick this scale again down here is you have to do what makes sense. So just look at your minimum and your maximum. So I noticed 103 and then like a 160, a 187. So that's why I picked that number. And then on the backpack weight, I saw a minimum of 24. I just started at 20 and then to 36, counting by 2s. And there, so again, what is the process in which I'm making this? I decided that this was my explanatory because of the x, and this was my response variable because that's my y coordinate, and then I labeled it, and then apply your individual points. Okay, so let's answer these questions here. Describe the relationships. Okay, so here's my describe word and the scatter plot above. So you need to be thinking about your SUDs. And what are my SUDs for this problem? So S stands for shape. What is my shape? Well, I think you can draw a line through this. So I think it's linear. What does our U stand for? Anything unusual. Okay, you could say that this one here is unusual. That is possible. You could say, what is that? 187.30. You can say that, right? Body weight, 187 pounds with a backpack weight of 30 pounds appears, we're not saying it is, but it looks like appears to be an outlier. Why? Because it's so far away from that line. Remember, my word here is appears. It's not like it must be. Okay, what is D? It is our direction. So is it positive, negative, or none? And we would say that that one is moving in the positive. And how about our strength? Okay, this one, again, you don't have a lot of details, but my question is it super close? Is it strong? Is it moderate or weak, like it's super far away? Everything's away from that. I would probably say this one is moderate. Okay, so that's my SUDs and describing my scatter plot, lesson target number 3. Let's go ahead and go to page 5. All right, page 5, almost done here. Let's go ahead and it says, what's going on? Describe the relationship shown in the scatter plot. So remember, when you see the word describe, you should be thinking of SUDs. So let's do this one together, and then you can do the last one by yourself. So what does SUD stand for? Remember, that is our shape, unusual, direction, and our strength. Alright, so what do I notice about my shape? It's kind of like a curve, right? I guess you could argue that somewhat linear. I think for this one, I'm probably going to say I like the idea of that curve. So let's write that. Here I have a curved relationship. So you can write a full sentence. The shape is a curved relationship. Do we notice any unusuals here? You could possibly point out these as outliers. Two possible outliers. You can also note that this is kind of like in two clusters. Two clusters. That's unusual, right? How about our direction? Our direction, I would say, is a negative direction, and then the question is, how strongly associated is it with that curved line? I'd say moderate, because you have those outliers kind of further away. Okay? Alright, go ahead and press pause. You try 6B and we'll finish this up. Alright, let's go. How do you describe here our graphs? Remember, this is also another keyword is called interpreting. If you're interpreting, then you're using your SUDs. So let's talk about our shape. Look like you could put like a line through it. So I would say a linear relationship. Linear relationship. Is there anything unusual here? I would say there's no outliers. No outliers. But I do notice two clusters. Seems like there's a cluster here and then a cluster break here. It's possible. There's something we're noting. How about the direction? Negative. And how about its strength? I would say this one is, again, moderate. I don't think it's weak, and I don't think it's super strong. We said there's possibly two clusters in this one. So there you have it. Lesson 2.2, the relationship to two quantitative variables. What did we do in this lesson? We talked about our explanatory and response variables, how to figure those out. We created scatter plots, and then we interpreted our scatter plots by using SUDs. Have a good one, guys.